Hey math lovers, let's go over 1.10 introduction. Our learning targets are standards for mathematical content. Interpret key features of a quadratic graph and tables and calculate the average, something called the average rate of change. Okay, how can I meet this standard? I can find the domain, range, and average rate of change of a quadratic functions found in the real world. Alright, let's go ahead and try this warm-up. You have two functions here, f of x and g of x, and in these 5 questions here, they are asking you to evaluate each of these. So what is f of 3? Here's my hint. If you put f of x over this, they're basically telling you that x is equal to 3. X is equal to 3. Press pause, and then when you want to see the solutions or you want me to do it with you step by step, go ahead and press play. Alright, so I have two functions here. Let's call this f of x the green one and g of x the yellow one. Okay, so you'll notice that the first problem has an f. So I'm just going to copy that. F of x equals negative 6x plus 2. And here, all we have to do is a substitution. We said that x is equal to 3, so I'm going to put that every time I see x. So instead of writing x, we're going to write 3. So f of 3 equals negative 6. And every time we do a substitution, you put it in parentheses. And here I'm going to use PEMDAS, so the order of operations. And this is telling me that multiplication goes first, left to right, before addition and subtraction. So negative 6 times 3 will give me negative 18 plus 2. And if you just simplify that, that'll give me negative 16. Okay, so I just want to talk about how this is essentially an ordered pair. This is your x value. So x equals 3. X equals 3. Think of an ordered pair. And then this is basically saying f of x equals negative 16. At 3, it's negative 16. That just means your y value is negative 16. So that will be an ordered pair, and you can graph that. Okay? All right, let's go ahead and try the next one. So our next problem is in yellow because I have a G and this one has a G. So I'm just going to copy that. And I'm going to write it right below it. G of x equals x squared minus 2x plus 5. And hopefully you recognize that your x value is what? Negative 4. So every x value, I'm going to write negative 4. Now this is super important because this is where students will make the mistake, is not using your parentheses when there is a substitution. So right here, all of x is negative 4 in parentheses, then you square it. Same thing, parentheses, and then plus 5. Now we just need to simplify and use order of operations. So I'm going to use PEMDAS. I'm going to use the exponent first. And so negative 4 times negative 4 is positive 16. Remember, this is multiplication here, so that's negative 2 times negative 4 is positive 8, and that is 5. Remember, that does not read negative 2 minus 4. That would be incorrect. So if you just add all those up, 24 plus 5, I get 29. Remember, the order pair would just be negative 4 comma 29 as your order pair. Okay, let's go on to the next one. Double check the answers are correct. Okay, this one tells me the function of f, which we said was what color? Green. But here's something different. It has n minus 2 in there. But let's just write out the function for x. F of x equals negative 6x plus 2. And we said that every time we see what's in the parentheses, so your x value, instead of writing x, we're going to write n minus 2. N minus 2. So no longer am I writing x, I'm writing n minus 2 with my yellow highlight. N minus 2 goes right in there. Okay, so what's different about this one is you have a variable, which is fine. You don't have to be scared of it. And I'm still going to use PEMDAS, so there's no exponents. In the parentheses, I cannot put n minus 2 together. They're not like terms. So right here, what I'm going to do is I'm going to distribute. This is multiplication, and I got to distribute everything inside. If I bring back a boba for my kids, you know, I can't bring it for one kid. I got to bring it for everybody. So everybody inside gets it. So negative 6n. Negative 6 times negative 2 is positive 12, and then plus 2. You could have done an in-between step in there if that's helpful for you. You could have done something like this. Negative 6 times n, and then negative 6 times a negative 2 plus 2. And then you'll see that how those come into play. And then I just need to combine like terms here, so that will give me a negative 6n plus 14. So in this problem, yeah, those aren't an order pair, but when I put in the into the function n minus 2, it comes out as negative 6n plus 14. All right, let's go ahead and try number 4. Number 4 is, what letter we got here? We got yellow. Okay, why am I choosing the yellow function? Because it had a g in front. Now pay attention. This g only represents this part right here. Okay, so let's just write it out first. I have g of x equals x squared plus, sorry, that's a minus, 2x plus 5. And I'm going to go ahead and highlight this part here, the plus 2, because a lot of students will forget that. So you can just write a plus 2 at the end. So let's summarize what we did. G of negative 1 is going to happen here in this yellow box, and the red there we can't forget. Okay, so we have every x value is negative 1. Every x value is negative 1. Let's write this in now. So I have G negative 1. Remember, every x value you must put in parentheses. It's a substitution. You just can't forget it. Okay, I'm just going to go simplify order of operations. I see parentheses and exponents. Negative 1 times negative 1. That's what it means, right? So you have positive 1. Remember, this is multiplication here, so that's negative 2 times negative 1, which is 2. Positive 2 plus 5, and don't forget that plus 2. And so if I finish the problem, 1 plus 2 plus 5 plus 2 gives me 10. And that would be our answer. G of negative 1 equals 10. And that's just a fancy way of saying the order pair, negative 1 comma 10. And then our last problem is going to combine two of them. So we had in yellow the g's, whoops, that's not yellow, the g there, so let's go ahead and write out that one. G of x is x squared, and you can do this two ways. You can do it like all together, you can do it separate. I'm happy, let's separate it. Let's just do two problems in one, okay? So I have g of x equals x squared minus 2x plus 5. And I keep forgetting what color we chose for the f is green. Then over here, that's right, f of x equals negative 6x plus 2. Let's finish this one first. So every x value is 2. So g of 2 equals 2 squared minus 2 times 2 plus 5. And I'm going to do the exponents, so that would be 4 minus 4 plus 5. 4 minus 4 is 0, so g of 2 equals 5. And then over here, we're going to do the same thing. Okay, now, if you get confused, you can just write above it f of negative 3. So that means every x value here is going to be negative 3. Every time I see x, I'm going to write negative 3. So I see an x, let's write negative 3. Order of operations. So multiplication before, remember this is not 6 minus 3, it's 6 times, because in between negative 6 and x there is no subtraction sign. So positive 18, caught myself, whoa. And this would basically be 20. Okay, so to marry these two, I just have 20 and a 5, which is positive, so you can write that your answer is going to be 25. F of negative 3 plus g of 2 equals 25. All right, let's go into our
What do footballs, long jumpers, and softballs have in common? They all follow the same rules of motion, but who makes those rules? The parabola. The parabola is what goes in the blank, so parabolas are good sports. The paths of projectiles vary in height, and distance traveled. So you can kick a football really high in the air, or maybe you want to go long, or kind of the perfect one. However, projectiles follow a parabolic path. It looks like a U. And here's a really big one right here. At its maximum height, a projectile's vertical motion is momentarily stopped. Okay, so I would say going from left to right, it's increasing and it stops right there, and then you go down and decreasing. So if you think about it, think about those roller coasters. I forgot is it Extreme Scream or something like that at Knott's Berry Farm? And it kind of, you do feel like almost weightless at the very top there. Now, if you ignore air resistance and gravity is the only force acting on this projectile. And then the force of gravity of Earth is constantly 9.8 meters per second squared. So it is the same, which is kind of cool, because if you drop a penny from a very tall place, or you drop like a brick, they will actually fall at the same rate. I wonder who created that formula. Every projectile starts with a push. It needs kind of energy. And the initial force launches this projectile. So let's just say, like my kids like to kick the soccer ball in the front yard, or a soccer ball, right? You need to actually put the energy into it. A projectile launched from the ground takes the same amount of time traveling to its maximum height as it does traveling from there to the ground. So if you kick this apple from over here and you kick it here, it's saying the distance right here is the midpoint, or we'll talk about later as the line of symmetry, and then it's the same amount of time. So if it took like 2 seconds to get up here, then it's going to take 2 seconds to fall down. I apologize, I don't know how to say her name. Galina Chichakova holds the women's long jump record of 7.52 meters, 24 feet, 8 inches. That's roughly the length of 2 cars. 2 cars goes in the fill blank there. I was like, no way, she could go that far. That is amazing. The highest basket toss of a cheerleader reached a height of 5.50 meters, or 18 feet is what you need to put in there. 18 feet, which is pretty crazy. That's almost twice the height of a basketball hoop. And of course, the GOAT, Michael Jordan, is legendary for his amazing slam dunks. He stayed in the air up to 0.92 seconds. That's why they call him Air Jordan. Alright, hopefully you were able to play around with this. So let's go ahead and set the default to 1. Can you just click a number? Oh yeah, you can just type in 1. Okay, so if you have a graph, you could, blue is kind of like the parent function, and they're not the same. Mother function, they call it sometimes. And then the green one is like your kids, like my kids. They look like me, not exactly, right? But I told you to put green there, so you can turn this off by just clicking on that. And then it says, what happens when A is positive? So if I go here towards positive numbers, I notice it's getting skinnier. And then if I go negative, what happens? It goes down. So this one would be positive. That would be up. And when it goes negative or less than 0, that's what numbers less than 0 means. It means negative. It's going to go down. And we said this one was up. Okay, set to default, so that means put them all back at 1. Isn't that song, cheesy love song, back at 1? Moving the b value, what is the y-intercept of this function? So here's the y-intercept right now. It is 1, and it's telling us move the b value. So what happens to the b value? So I notice when the b value moves, when we move the b value, the y-intercept stays the same, but the graph moves. Moves. What happened when it was positive? Alright, so when it's negative, it moves towards the right, and when it was positive, it moves to the left. When b was positive, it moves to the left. When b is less than 0, or negative number, the graph can't spell, graph to the right. So if we set it back to the default, it says, for number 7, what happens to the graph as the value of c changes? So if I go positive, it goes where? Up. And if it's negative, it's going down. So did the graph go vertically, up and down, or horizontally, left and right? It went vertically.
All right, let's go over these are the answers for the launch. Let's go under Explore now. Go ahead and click on that. And you have this Desmos kind of graph. The green graph represents the parent function, and the blue graph represents the kid function, right? If you took out a picture of my kids, they look like me. Some people call these the mother function. And when you click on that, it says set a equals 0, a equals 1, b equals 1, c equals 1. We're going to call this the default. So anytime I say reset it to default, a, b, and c are both 1. Go ahead and do that, and then see if you guys can answer these couple of questions, and then we'll go over that together. All right, we just went over the Explore. Let's go ahead and go over some vocab. A function with with an equation of the form y equals ax squared plus bx plus c, where a is not equal to 0. This is called a quadratic function. The line, so Let's draw a graph here, that might help. This is my graph. And this is my quadratic function. Let's draw something like this. Let's change that to red. Okay, quadratic function. Okay, my next one is the line about which the graph is symmetric. They call this one the axis or line of symmetry. Now, sometimes people will abbreviate it as AOS, axis of symmetry or line of symmetry, and this is the green dot here. Back in geometry, we would have said something like a angular segment bisector. It cuts it in half. Okay, let's go purple here. Either the lowest point, which we call the minimum, write that, or min for short, or the highest point, which is also called the maximum, on a parabola. This is called the vertex. Okay, so let me go ahead and locate the vertex on ours. Okay, now pay attention. The vertex, let's say this is a skateboard ramp. It's the minimum in our graph because it's pointing up. But I also want you to notice that actually the axis or line of symmetry goes through. It goes through the vertex. So they actually have the same x value. Okay. How a quantity is changing with respect to a change in another quantity. This is called rate of change. Rate of change. And then the last one, change different color here. The change in the value of the dependent variable divided by the change in the value of the independent variable. This is called the average rate of change, which we're going to learn later on. Okay. Let's do a couple of things here. Okay, here, this whole term here in orange, they call this the quadratic form. Sorry, I'm so zoomed in, it's going to be pixelated. Quadratic term. This green one here is called the linear term. Why is this linear? Is because x is to the first power right here. It's invisible. Quadratic term because it has the power of 2. And then this one that has no x, this is called the constant. Now, I do want to bring up some previous knowledge. You learned back at linears y equals mx plus b. And what's confusing is that b was the y-intercept. Now the y-intercept is the c in quadratics. M was the slope that's in front of x, but just to the first power. But I just want you not to confuse the b values. Okay, let's use the vocabulary words to kind of get some formulas here. The axis of symmetry, or the line of symmetry, I'm going to call it AOS. Here, formula is x equals negative. Okay, I like to draw my fractions up and down. The negative sign is in the same line as a fraction. I'm going to write b over 2a. Sounds like the beginning of a song. X equals negative b all over 2a. I know, you don't like me singing. Okay. What color do we use for the y-intercept? Okay, so the c value, which we talked here in blue, this is also your y-intercept. So that is here, y-intercept. It's where it crosses the y-axis, right? That's the x. And one last thing that I want to point out, which is kind of cool. Yes, math is cool. is this line here. And if you go from the dark blue to the green, this distance is equal to this distance, right? And so they just call this a reflection of the y-intercept. Okay, so that is our vocab. Let's go ahead and move on now to 1.11. All right, here we're going to graph a quadratic function by using a table of values. A table of values. It's a chart. And our first example here says graph f of x equals x squared plus 2x minus 3. A couple things I want to point out is don't be intimidated by this f of x. Just a fancy way of saying y. Okay, so the first thing I want us to do is to analyze, or a better word, I think, in math is to evaluate the function, kind of like we did in our warm-up. In order to do that, you're going to have to find your axis of symmetry. Axis of symmetry. Remember that formula from the previous one? X equals negative b over 2a. Okay, this whole big idea here that we're learning is something called standard form of quadratics. Let's write that really big. Standard form. And why is that a big deal? Because there's a couple other forms we're going to learn. But I'm going to go ahead and write standard form right here, which was on the previous one. Y equals ax squared plus bx plus c. And basically what I'm going to do here is figure out, well, a is in front of x squared. So that means a equals 1. It is the number in front of x squared. There is no number, it is not 0, because 0 times anything is 0, so it is a 1 there. A is equal to 1. Right here, b is equal to 2. It is the coefficient or number in front of x. And c value is 1 by itself here. That is a minus 3. So if it has a negative, then you have to include it. Okay, let's go ahead and find the axis of symmetry. So I'm going to have x equals my b value, which is 2, will go here. And then my c value, a value, which is 1, is going to go right there. Now, pay attention. It's right next to the 2. And then we could just simplify this. X equals 2 over 2. And 2 divided by 2 is just 1. Or when you cancel them, you can kind of say this is like a big 1 right there. So the answer is negative 1. Let's box our answers. The axis of symmetry is negative 1. Okay, that one was so important. So important. Because now, in step number 2, we're going to do something called graph the function. We're just going to graph it. And I need to point this out big time. X equals negative 1 goes into the middle of our chart. Everyone say middle. This is so important. Okay, the axis of symmetry is going to help you pick values bigger and smaller. So let's just make this a number line. And let's say this is negative 2, negative 3, and this would be 0 and 1. So the axis of symmetry helps me pick these other x coordinates. To graph the function, let's just write it up here. And we're just going to basically do what we did in our warm-up. We're going to evaluate our substitute. So let me give you a big idea here, okay? All these x values, we're going to basically do 5 mini problems, and every x value will be based on what's there on the left side. Does that make sense? So let's do the first one. We said negative 3. So negative 3 squared is 9. 2 times negative 3 is negative 6. And that's minus 3. So 9 minus 6 is 3. And 3 minus 3 equals 0. Okay, now pay attention. the 0 is the y value, or f of x. And the x number was what I highlighted over here. Does that make sense? So I have an ordered pair of negative 3, 0. And that's the number we were substituting. So my ordered pair is going to be negative 3, 0. Okay, let's do the next one. We said that every x value now is going to be what? What does it say over here? It says negative 2. So let's go ahead and substitute in negative 2. And we're kind of just basically doing 5 mini problems like we did in the warm-up. Negative 2 squared is negative 2 times negative 2, which is 4 minus 4 minus 3. 4 minus 4 is 0, so you're left with just negative 3. Now remember, this table of values is all contingent, or most important to know that the axis of symmetry is negative 1, because that tells us the middle of the numbers, and you will always pick at least 2 values above it and 2 values below it. Okay, let's do this one here. So now I have negative 1 squared plus, we're substituting with parentheses. Order of operations is simplify, so negative 1 squared is 1. Don't be shameful to use your calculator. It's okay. I'd rather use a calculator than make a mistake. But I definitely want you to know how to do it. 1 minus 2 is negative 1, and negative 1 minus 3 is negative 4. Oops, I forgot to write the other value. So again, over from here, that's negative 2, and over here, it's from negative 1. Hopefully you're getting the hang of this. All right, in the parentheses, now we're putting 0. How did I get 0? Because that's the number over here, and it's a number next to the axis of symmetry. We always love 0. 0 squared is 0. 2 times 0 is 0, minus 3. So now I have negative 3. So that would be an ordered pair of 0, comma, negative 3. And our last one, 1. Let's go ahead and substitute in 1 here. So I have 1 squared plus 2 times 1 minus 3. 1 squared is 1. 2 times 1 is 2. So 1 plus 2 is 3, and 3 minus 3 equals 0. So my order pair is going to be 1, comma 0. Okay, so that's how you graph a quadratic function standard form, get to order pairs. And let's go ahead and graph this now. Okay, let's graph this one over here in black. So again, you have your x's, and this over here, the y-axis is like your f of x. Remember, that's just a fancy way of saying y. So my order pair is negative 3, 0. So if you've never graphed before, you'll notice on the graph over there, the x values are left to right, and f of x, or the y-axis, is just up or down. Right? X goes this way, and y values go that way. Okay? So for the first order pair, I'm going to say negative 3, comma 0. That means I have to go left or right. Well, negative is to the left. And then 0 means just stay. So there's my first order pair in black, negative 3, comma 0. Okay, 2, 3. Negative 2, negative 3 is negative 2 on the x-axis. So that means left 2 this way. And then negative 3 means, is it up or down? Well, negative values are down, so it would be right here. Okay, so we did this one. Now let's do this green one. Negative 1, 4. So negative 1 on the x-axis, so that would be left 1. And then negative 4 would mean down 4. So right there. And then let's do the blue one, 0, negative 3. So I would, on the x-axis, it's at 0. And then you're going to go down negative 3. And the last one, 1, comma 0. So that'll be right 1 and then stay, or 0 on the y-axis. Okay? Let's pick a nice color. How about? And remember, this is not a v. That's a different function. This is a parabola. Let's It's meant to be smooth, which I didn't do a great job of. Okay, one thing I want to point out is the axis of symmetry, the middle one. And what's important is, you know, you can see that my graph's kind of being folded on that axis of symmetry. You're folding your taco or something like that, right? And then we already did step 3, basically. This part says analyze the graph, because the second part of it tells us state the domain and range. Okay, so quickly, domain is another way of saying your x values. What x values can I pick? And you go from, I say a phrase, left to right, left to right. The range is your y values. And I want you to go from bottom to top, bottom to top. Okay? And I'm going to show you guys this with inequalities. Inequalities. Okay, so I'm going to use my highlighter. That's fine. Let's pick a different color. Let's pick orange. And you're just looking, does the graph have it? Yes or no? Are there x values over here? The answer is yes. The reason why is that arrow will keep making the graph go up. So there are values there. Yes, 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 yes. Okay, even over here, there is x values, or the graph is there because the arrow is going up. So basically you can pick what? All numbers. So, whoops. So the domain, we would say, is all real numbers. I can pick every x value, and the graph, you can get a graph. So even over here, 4, or somewhere on the x values of 4, is there a graph up here? There is, because remember I said this graph's going to keep going up. It's going to touch it, so. Okay. The range, as you see, it says bottom to top. So let's go ahead and try this. So I'm going from the bottom. Okay, pay attention. There is no yellow graph. There is no yellow graph. There is no yellow graph. Okay, right here is where the graph starts. Okay? Look at the y number line, the f of x. You see that it's touching that number line at -4. Is there a graph? Yes. Is there a graph? Is there a graph? Yeah, is there a graph? Yes, there's a graph, there's a graph, there's a graph. So starting at -4, and when the values were what? Bigger or smaller than -4? When the y values, so the range is when the y values were at -4, -3, -2, those are bigger or greater than or equal to -4. It's an equals to because it's a closed circle, which means any point on the graph is a solution. If you want to get super fancy, I'm going to write here in black, we have something called set builder notation. And just in this set, your variable is y, such as that y is greater than or equal to -4. That basically is saying that all of my answers for the graph on the y-axis will always be -4 or more. So you should never get a value such as -1, -5 as a solution, because it doesn't touch the graph. All right. So that was our introductory problem. You must have filled that out. And let's look down here. This one says graph each function, then state the domain and range, and complete a minimum of 3 problems. Complete a minimum of 3 problems. Go ahead and pick your 3, then cross them off, and then if you want to see me do them all, go ahead and press play, or you can kind of fast forward it to move to the problem you want. Okay, so we're graphing these problems in standard form, and you'll notice that standard form basically means you can find your A, B, and C. So let's go ahead and do that. You can write standard form above it. What is this? This is one of our 3 forms, and so it's standard. Here I got A equals 1, B is 6, and c equals 8. I'm always going to write down my formula for the axis of symmetry, that is x equals negative b over 2a. I'm going to do my substitutions here. So a is equal to 1. My b value is positive 6. So then this is going to give me 2 times 1 is 2, so I got negative 6 divided by 2, and then you get negative 3. So then if you make your table of values, just like we did above, so this is x, this is my function, and then this is the ordered pair. Right? The most important is the axis of symmetry will go in the middle. Okay? Not here, not here, no, no. This one in the middle. That is very specific. You must have that. Okay, now you need to fill it in. So numbers that are higher. And you can just look at what we did before. You can say negative 4, negative 5, negative 2, negative 1. Okay? And if you pick consecutive numbers, meaning you don't skip, you just add 1 or subtract 1 from negative 3, you're going to get something very nice on your graph. Okay, we said that basically all of these x values are going to go right here. Every time I see x, every time I see x in that column, you're going to write that. Okay, so let's do the first one. So I have negative 5. That f of negative 5, you don't really do anything. You just need to simplify over here. So this will be negative 5 times negative 5 is 25. Positive 6 times negative 5 is negative 30 plus 8. So 25 minus 30 is negative 5. Negative 5 plus 8 will give me a 3. And so I will get the coordinate negative 5 comma 3. Okay, let's do negative 4. Negative 4 squared plus 6 times negative 4 plus 8. Negative 4 squared is 16 minus 24 plus 8. So I'll get minus 8 plus 8. That'll give me 0. Negative 4 comma 0. All right. Negative 3. Substitute it in here. Every time I have that green, I'm replacing it with the x value of negative 3. Negative 3 squared is 9 minus 18 plus 8. So 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So negative 3 comma negative 1. We're going to do the same thing over here. So I have negative 2 squared plus 6 times negative 2 plus 8. Every x value we're making negative 2. Negative 2 squared is 4 minus 12 plus 8. And 4 minus 12 is negative 8. And negative 8 plus 8 is 0. So that would be negative 2. And the last one would be negative 1 squared plus 6 times negative 1 plus 8. So 1 minus 6 plus 8, this would be 1 minus 6 is negative 5. Negative 5 plus 8 gives me 3. And if you notice something, that if you find the axis of symmetry, you'll notice that in my last column there, all of the order pairs that are blue are what? The y values are the same. And in the black ones, there the y value is the same as 0. So let's go ahead and graph this now. Negative 5, 3, left 5 on the x-axis, 3 on the y. There's my blue. Black, negative 4, 0, left 4, stay. Negative 3, 1, left 3, down 1. Black, negative 2, 0. and negative 1, 3. Left 3, up 1, because the y value 3 there is positive. And this is our graph. Okay, to double check yourself, let me go ahead and show you guys graphing calculator. All right, I'm going to go y equals in the top left. Clear that. Okay, my trick for getting x squared is just typing xx. Now don't use, if you see letters on the bottom, you want to go next to alpha. The green button, and it says x. So x times x means x squared, so go ahead and type that in. Plus 6x plus 8. And you can go to something called your table, so it's above the up key, so second, no, I don't have to press second, just press table. Okay, mine, I have something, so you can change it, so second table, and you can highlight auto if you want, since they're whole numbers, and then go back to table. Oh, I know why, let's go back, sorry. Okay, so you go back to table. Basically, I don't know if you guys recognize just what happened. It has all the answers. Whoa, the calculator already has it. And if you just press graph, watch this. Whoa, that's the graph that we graphed. And watch this, if you touch the point, whoa, it tells you all the ordered pairs, right? Like, this is not a fun ordered pair. It is a solution, negative 2.8 and 6.35, but it's easier if it just goes through a point like that. That's like negative 1, 3. Does that make sense? Whoa, negative 2, 0. Negative 3, 1. So quick ways for you to check your answers. It's not to copy, but for you to know it. Okay, question number... all right, let's go over question number 2. Graphing quadratics in the standard form. I'm going to find our A, B, and C values so I can find the axis of symmetry. I'm going to write standard form right above it. There is no number, that means it's going to be a 1, negative 1. B is negative 2, and C is 2. My axis of symmetry formula, x equals negative b all over 2a. All right, let's just put that in there. So I like my negative sign and same line with the fraction and then vertically. So negative 2 over 2 times your a value, which is negative 1. So this becomes negative 2 over negative 2, and that equals just 1. So x equals negative 1. Okay, that means when I create my table, do that one for the formula. Uh-oh, ran out of space. Hopefully it doesn't go in there. So that's my x value. Here is the formula. And here's my order pair. And what's most important is taking this value here, x equals negative 1, and put it into this box. Notice how it's in the middle. There's 2 boxes above and below, and then you just fill that in. So what goes above negative 1, negative 2, negative 3, or you can choose 0 and 1, and you can just go in this direction, so it doesn't matter. And remember, all of these numbers are going to go here, 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 and here. So let's do the first problem. Whoops. So we're going to put in a f equals negative 3. So every x value is negative 3. Do you notice how to put that subtraction sign, negative sign on the outside there? And then order of operations here. Pay attention. This one's going to be negative 3 squared, which is 9, positive 9, and the opposite is negative 9. You do not distribute the negative 1 there. Okay, negative 2 times negative 3 is positive 6 plus 2. So negative 9 plus 8 equals a negative 1. So I have a negative 1 when it was negative 3. All right, let's do negative 2. Negative 2 squared is 4, and the opposite of 4 is negative 4. Negative 2 times negative 2 is positive 4, plus 2. These will, negative 4, positive 4 is 0, so you're just left with 2. So my order pair is negative 2, 2. All right, let's go ahead and put in here negative 1. Forget that negative sign. So I have negative 1 squared is positive 1, so negative 1. Negative 2 times negative 1 is positive 2, and positive 2. So negative 1 plus 2 gives me positive 3. So negative 1, 3. And let's put in 0. Zero squared is 0. Opposite of 0 is 0. 0 times negative 2 is 0. And so you're just left with 2. So that would be 0, 2. And the last one, 1. So 1 squared is 1. Opposite of 1 is negative 1. Negative 2 plus 2. So these will cancel, and you're left with negative 1. Let's go ahead and graph these. Negative 3, negative 1, so left 3, down 1. Purple. Negative 2, up 2. And I'm going to do this one, because I have my purple pencil out. 0 on the x-axis, 2 on the y. Negative 1, 3, so left 1, up 3. And 1, negative 1, right 1, down 1. There is our parabola. This is our axis of symmetry. And let's figure out the domain. And if you've learned the trick, left to right, if you just have 2 arrows, there's an arrow, there's an arrow, so you have all x values. So all real numbers. So basically as you're going left to right, there's 2 arrows, it's always going to be all real numbers. We can always put in something here. Okay, for the range, just write down the vertex order pair, and then you'll kind of see this negative 1, positive 3, and there's something down here, it's the arrows, which means there's always numbers down here. But it stops right here on the y-axis at 3. So is the graph getting greater, going to the greater numbers of y value on the y number line, or less than? So that would be what? Less than or equal to 3. All right. Question number 3. We got our ABCs. And then we're going to get our axis of symmetry. X equals negative b over 2a. And we're going to substitute those in. So Negative 4 goes here. And then A is 2. So we're going to get negative 4 over 4. Negative 4 divided by positive 4 is negative 1. Opposite of negative 1 is positive 1. Okay, super important for us because we make our table of values. Do I have too many there? I think I have too many. Let's see, 1, 2, 3, 4, 5. Too many. Just erase that one. Boom. Okay, so I have my x. I have my formula, or my function here. And then the order pair. Okay, put your finger on where the x equals 1 goes. It's going to go into this box right here. Why this box? It is the middle of your points. So you can go up or down from here. So 3, 2, 1, 0, and negative 1. You want consecutive integers, just basically means you're counting there. And then we're going to do this multiple times. So from here, you're just taking all of your x values and you're putting them in here. Function notation you don't really need. So let's go ahead and do this one. So 3, so 2 times 3 squared minus 4 times 3 plus 3. Remember, do not do 2 times 3. Why? Because you see it and you're tempted, but order of operations tells you the rules. So that's really 3 squared, which is 9. 9 times 2 is 18. Negative 4 times 3 is negative 12 plus 3. So I have 18 minus 12 is 6. 6 plus 3 is 9 is our answer. Whoops! Do you see my mistake? 9 should not go there. That should go for your output or your answer. X was in orange, so that would be 3, 9. Alright, let's go ahead and try 2 now. Remember, every time put in parentheses, order of operations, parentheses exponent, so 2 squared is 4, 4 times 2 is 8. And 8 minus 8 is 0, so I'm just left with 3. 2 is my orange color, and then 3 is my answer, f of x. Okay, let's do this middle one here. Remember, that's essentially just f of 1, but you don't have to write it every time. 2 times 1 squared minus 4 times 1, because you're replacing it with your x equals 1. 1 squared is 1. 1 times 2 is 2 minus 4 plus 3. So negative 2 plus 3 gives me positive 1. So my order pair is going to be 1, comma 1. I got 2 times 0 squared minus 4 times 0 plus 3. 0 squared is 0. 0 times 2 is 0. Negative 4 times 0 is 0. So I'm just left with 3. 0, comma 3. And the last one, negative 1. 2 times negative 1. And remember, every x value, we're now writing negative 1. Negative 1 squared is 1. 2 times 1 is 2. What did I just say? Negative 1 squared is 1. 1 times 2 is 2. Negative 4 times negative 1 is positive 4 plus 3. So 2 plus 4 plus 3, that would be 6. That would be 9. So I'll get negative 1, comma 9. Let's go ahead and get our pencil. 3, 9. Don't have on the graph. That's bad. Okay, so let's extend it. 6, 7, 8, 9. Okay. So 3, 9. 2, 3. Right. 2 up 3. 1, 1. 0, 3. And the points should be symmetrical, right? So 1, 2, left 1, up 2, but it gives you to the same point. And then black, negative 1, 9, left 1, up 9. So here's my graph. I need a darker color. And again, my trick is just to write this 1, 1 here. And so the domain is, remember, you're going left to right. A little bit kind of crazy, but I'll just draw these lines. And the first thing is you hit an arrow, and in this direction you hit another arrow. That means it's all real numbers. Again, that basically means you can pick any x value and put it into our function. Okay, the range, now we're going from bottom to top, bottom to top. And look at the y number line. Nothing, 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 right there. You're starting at 1. Yep, and it keeps going till forever with the arrows, right? So y is greater than or equal to 1. I got 1 because the graph's starting right here, and it's greater than because it's going above to bigger numbers, 2, 3, 4, 5. All right. Let's do number 4. Okay, this one's a little bit tricky in that there's a bunch of stuff missing. So you can just write, look, watch, write standard. You have stuff missing, so just write zeros. See that? And then you can just quickly identify your values. A is negative 2, B is 0, and C is 0. All right, my B value is 0, and my A value is negative 2. So I have 0 divided by negative 4. 0 divided by any number is 0. The opposite of 0 is 0. So x equals 0. Whoa, that was cool. Sorry. Oh, cool. Wait, let's see. Oh, it makes straight lines. Sorry. Okay. Let's make a table of values. See? Oh, that's so cool. I learned if I hold it down, it makes like straight lines. Whoa! Sorry, I got so excited. Oh, my notes are going to look so much better. My lines are going to look so much better, guys. Are you excited? And let's draw one right there. That's so cool. All right, f of x equals negative 2x squared. And over here, it's kind of tight, but it's the order pair. Okay, so put your finger on where that value should go. This one should go in the middle here. Why? This box right here, there's 2 above and 2 below. You want it to be in the middle. So I have, let's see, what's the numbers going above it? Doesn't really matter. You can do like 1 and 2, so you can count down 2, 1, 0, negative 1, negative 2. And all the x values you're going to put in right there and right here. You could put into the f of x, not wrong. All right, let's see what we got. F of 2 equals negative 2 times x, which is 2 squared. Don't forget your PEMDAS. So 2 squared is 4, and 4 times negative 2 is negative 8. So my answer is negative 8, and I put in input of 2. 2 comma negative 8. All right, let's do 1 here. F of 1 equals negative 2 times 1 squared. And 1 squared is 1. 1 times negative 2 is negative 2. So that's my answer. 1 comma negative 2. Remember that x value right is inside right there. and that's why it goes right there. Okay, so now we're putting in 0, f of 0 equals negative 2 times 0 squared. Order of operations says do the exponents first, so 0 times 0 is 0, 0 times negative 2 is 0. So I have 0, 0. And we're going to put in a negative 1 here for every x value. Negative 1 times negative 1 is positive 1. 1 times negative 2 is negative 2. Remember, don't have any shame. Use your calculator. So I have negative 1, negative 2. And then the last one in blue here, I have a f equal f of negative 2. This is going to be negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So I have negative 2, negative 8. All right, let's go to our drawings here. So 2, negative 8. Okay, so if you do what I did, I messed up. And I don't have, I'm so happy, and draw straight. Okay, so 5, 6, 7, 8. That one's negative 8. Okay, so 2, negative 8, write 2, then down 8, because the y value is negative. And then I have 1, negative 2, so write 1 down 2. 0, 0 is the origin, so you stay right in the middle. And then left 1 down 2. And then left 2 down 8. Whoops. And then pick colors, pick red. Okay, our domain, remember, is left to right. Nothing, nothing. Arrow, that means all the numbers to the left. Keep going. Arrow again, that means numbers to the right, and that's all we're concerned about. It doesn't matter if it's up or down, so this would be all numbers, all real numbers. I can pick any real number, put it into my function, and I'm going to get an answer. Whoops. Okay, the range is going from the bottom to top. So I have nothing, but essentially you do have, the arrows keep going down forever. So that means there's numbers down here, but we're going to stop where? On the y-axis. That is 0. So our numbers are going to be y and 0, and numbers greater than or above, or are they below and negative? They are below, so they'll be less than or equal to. It's equals because it's a closed circle, which means include that solution. All right, let's do number 5. Put standard form right above it. There's no number, it's a 1, so A is 1, B is negative 4, and C is 4. And I have my axis of symmetry, which is x equals negative b over 2a. My a value is 1. And my b value, negative 4. Okay, let's simplify this. So negative 4 divided by 2 is negative 2, and the opposite of negative 2 is positive 2. Let's build our handy-dandy chart. So excited to learn how to draw straight lines. My mother would be proud of me. Doot. 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 Those are handmade sounds. Doot. 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 And that's our x value. Then you have a function here. Did you guys know about functions? They are fun. Okay. Alright, most important, where does that number go? Where does this number go? Right in the middle, which is right here. So I have 2 boxes above, 2 below. You can count up or down, does not matter. Let's count up and then down. And if you want to highlight, these are the numbers. So all your x values will go everywhere there's x. Okay, why did I not do it on the far right column? Remember, f of x is the same thing as your y values. So you could just say y equals all that stuff. If that kind of messes you up or helps you, then use it. Okay, substitutions we put in with parentheses. Feel free to use a calculator. 4 squared is 16. Negative 4 times 4 is negative 16 plus 4. So that equals 0, and we're just left with 4. So my order pair is going to be 4, comma 4, because our x value is 4, and my y value, or my output, or my answer is 4. Okay, let's do 3. Feel free to use a calculator. 3 squared is 9, minus 12 plus 4. So 9 minus 12 is negative 3. Negative 3 plus 4 is positive 1. My answer is 3, comma 1. Alright, let's do 2. 2 squared minus 4 times 2 plus 4. Replacing all the x values with 2 because it has 2 over here. And 2 squared is 4. Negative 4 times 2 is negative 8 plus 4. So negative 4 plus 4 is 0 as my answer. What did I have to put in there for x? That was 2. And I have 1 squared. 1 minus 4 plus 4. So negative 4 plus 4 is 0, so you're just left with 1. My answer is 1, comma 1. My x value is 1. My answer was 1. And the easiest one is 0, because most of it will go away. Okay, 0 squared is 0. Negative 4 times 0 is 0 plus 4, so I get 0, comma 4. Let's graph it. So 4, 4, right 4, up 4. 3, 1, right 3 on the x-axis, up 1 because it's positive. Whoops, see, didn't pay attention there. Then my purple color, right 2, stay, or 2, 0. Uh-oh. See, here's a mistake. No, it's not. Right 1, up 1. If it's not have a parabola, then something's wrong. And then 0, 4. Let's go ahead and draw my parabola here. That's my graph. And then we can answer the domain. Domain is the x values are going left to right. Nothing, nothing, arrow to another arrow, which means the graph keeps going towards the right. So if it goes all the numbers to the left and all numbers to the right, then it is all real numbers. Interval notation, that would have been negative numbers to positive numbers. We would have written something like this. Left to right, left to right. Alright, let's go ahead and erase all this. And the range. Range goes from bottom to top. There is nothing, 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 nothing. And we start there. Go back to the y-axis, which is 0. And the numbers, or the graph, is above on the y number line, which is 1, 2, 3, 4, 5. So that would be greater than or equals to is your answer. If you wanted to know interval notation, you would start at, turn your head sideways, it's starting at 0, which is a bracket, which means include, and then you're going up, which is all the positive numbers, which we call infinity. So that's what the interval notation would look like for the range. And question number 6, x squared minus 6x plus 8. Make sure that's correct, because it's pretty much the same problem as the first one, but that's okay. All right, so I have standard form. So that's what we've been doing, the big idea. A is 1. It's a number. It's never a letter. B is negative 6. Okay, I know a student gets it wrong because they write like a variable like negative 6x. That would be wrong. And C is 8. Okay, axis of symmetry. X equals negative b over 2a. B is negative 6. A value is 1. Let's put in everything else. So x equals negative the fraction line and then the 2. So this will read negative 6 divided by 2 is negative 3. Opposite of negative 3 is positive 3. Let's go ahead and make our table, which I'm excited for because now I know how to draw straight lines. Boop. 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 Do you like my sound effects? Those were handmade or came from me. F of x, writing the function here. And then the order pair. X, f of x. Okay, so most important is this number. It goes right here in the middle, always. Why is that important to us? Because it actually tells us what kind of numbers to pick from here. I think it's easiest just putting that number in the middle and then counting numbers by 1. So 4, 5, so it's counting by ones. Okay, so all these x values you're going to put in here and here. You can put in the f of x value, but I don't want you to get confused on those. So let's go ahead and just do a substitution. Okay, so x value is 5. So 5 squared is 25 minus 30 plus 8. So negative 5 plus 8 is 3 is my answer. The x value you put in there is 5. 5 comma 3 is our answer. Here we're going to put in 4 for our x value. 4 squared is 16 minus 24 plus 8. 16 minus 24 is negative 8. Negative 8 plus 8 is 0 is my answer. And 4 was the input. 3 squared minus 6 times 3 plus 8. 9 minus 18 plus 8. I get negative 9 plus 8, which is negative 1. And what are we doing? Going back to green. I don't know if you guys noticed the color coding. I actually I'm doing this on a specific reason. The reason is so that it kind of matches when you graph it. You'll see. So 2 squared is 4 minus 12 plus 8. So negative 8 plus 8 is 0. So 2 comma 0. And if you notice, my green answers there on the far right, the zeros for y-axis are the same for 2 and 4 because they are reflective. Ah, that's why. And 1 squared minus 6 times 1 plus 8. 1 minus 6 plus 8, so that's negative 5 plus 8, which is 3. So 1 comma 3 is my answer. Let's go ahead and graph that. 5, 3, so right on the 5 on the x-axis, and then 3, up 3 on the y-axis. 4, 0, so right 4 on the x, then stay. Right 3, down 1. Right 3 from the origin, down 1. right 2 stay because it's 0 on the y-axis, and last one, right 1 up 3. Got a graph right here. Let's do the domain. Okay, although there's nothing over here on these graphs, you will touch an arrow and you will go to this arrow. So everything that has the arrow basically says you can pick any x value. Any x value. So domain is all real numbers. And then the range goes from bottom to top, nothing, nothing, nothing right there. So your y value is at -1. Notice how the graph is now going to greater numbers. So greater than or equal to -1 is my answer. And that's how you complete graph the function, state the domain and range, and we completed a minimum of 3. Hopefully you picked your 3. Let's move on to the next one. Comparing quadratic functions. So now we're just using our properties. And for 7 and 8, you're going to have to use the same graph here. Compare the graph of f of x. Let's color code this. To a quadratic with g of x. Okay, so g of x, we don't have one, so let's draw one. G of x with a y-intercept of +1 and a vertex of 1, 3, right? 1 up 3. Okay, so if I if I draw this graph now, you can make it symmetrical. What does that mean? From the vertex, you can draw that line, and then any point they're going across. Did you see that? This is 1. This is a distance of 1. That's how I knew it to draw it specifically through that point. Okay, then it says which function has the greater maximum. That would be this blue graph g of x, because the y value max is at 3, and this one is at -1. So let's write that. G of x, come to me. G of x has a greater maximum because its y value, what did we write on the graph there, is 3 compared to -1. Okay, let's try the other one. Compare the graph of f of x, which is already there, called the parent function, and let's talk about the kid, to the quadratic function of g of x, let's use red, with a y-intercept of 0.5, so that's between 0 and $1. So the graph's going to go through there, and a vertex of -1, -5. So left 1, down 5. 1, 2, 3, 4, 5. Okay, so this is the vertex. So the graph, I want you to pay attention, the graph is not going to do something like that. That would be wrong. Because the y-intercept, it goes through the y-intercept, but that is not the vertex, or the lowest or highest point. Does that make sense? So the graph must go, watch this. Remember, through the vertex, pencil, color, something. Let's try that again. I totally missed it. Come on. Oh yeah, now I can do a straight line. So this is the axis of symmetry, and it's going through that exact point. Does that make sense? So then 0.5 going across goes like right here. Does that make sense? So I know my graph is going to do something like this. Okay? Now it says which function has a lesser or smaller minimum. So my minimum here is at 1, 2, 3, 4, 5, and this one is at -1. So which one is smaller? Remember, smaller numbers on the y-axis, this is the bigger numbers, so -5 is smaller. That would be on our red graph, which is g of x. G of x has a smaller, or lesser minimum because it's, oops, something crashed. Oh no. Hope it saved it. Be forever mad. Blah! It erased it, but we're recording. So g of x has a lesser minimum because -5 is smaller than -1. I forgot what it looked like, but something like that. Does that make sense? So that one was at -5, and this one is at -1. Okay, let's do number 9. Okay, now it tells me an equation. F of x is x squared minus 10x plus 5 to the quadratic function g of x shown in the table. Which function has a lesser minimum? Okay, we have to do a little bit more work. Okay, so g of x is over here on the table. And what's the smallest number we have there? So you can just graph this, okay? Let's do something like this. I'm going to do 5, 10, because I see it's counting by 5s. And then I'm going to do something crazy like the maximum I see is like 200. So this is like 200, this is 100. So -10, 170, something like this. That, 0, 10, right there. 5, -10, so something like that, and then comes back up to 10, 10. Okay, so the green graph, I have something that looks like this. I'm trying to get a visual. Does that make sense? I think it helps students. Okay, so f of x, we don't have anything. But if we use the table of values from the last problem, we can get one. And then we can just basically figure out the order pair. Okay, but I don't have to do all 5, I just need to do 1. So A is 1, B is -10, and C is 5. I'm going to use the formula for the vertex. B value is -10. A value is 1. So -10 divided by 2 is -5. Opposite of -5 is +5. Okay, so normally we would do the chart, right? But you could just substitute that into the function. Whoops, I forgot to draw the 5. Let's just erase that. And let's make it a different color. Whoops, now I'm messing up. Okay, 5, 5, 5. So this would be 25 minus 50 plus 5. So -25 plus 5 is -20. Okay, let's graph that. 5, -20. So that is this order pair right here, right? Remember the order pair? And that's lower, isn't it? So we can say that, whoops, supposed to be blue. So it doesn't matter if the graph looks like this. It can look like this. It doesn't really matter. It's just it has a lower minimum, this point right here. So f of x has a lesser minimum because, so when it says explain, that's the word because in math a lot of times. -20, right, is lower than, what was our number over here? What's the lowest number on our y values? -10. Okay? All right, let's try number 10 here. Let's do the same thing. Let's just go ahead and graph this one. So I see on the x values they're counting by threes. Okay, then the lowest point is negative 26, so counting by maybe 5s. Negative 5, negative 10, negative 15, negative 20, negative 25. Does that make sense? And let's go ahead and graph this. Negative 6 down negative 26. Negative 3, negative 11. 0, negative 2. Right 3 up 1. And right 6 down negative 2. And notice those values are the same. That's why I have it kind of at the same point there. And then our graph is going to look like that. And then I can do the same thing for the problem we just did. A is negative 1, B is 6, and C is negative 15. So, vertex 6, A value is negative 1. So 6 divided by negative 2 is negative 3. Opposite of negative 3 is a positive 3. If I put that into function notation, substitute a 3 in for every x value. We're going to get 3 squared is 9. Then you multiply by negative 1. So negative 9 plus 18 minus 15. 9. So that would be f of 3 equals negative 6. So write 3 down 6. And I know it's facing down because the a value is negative 1. So it's going to look something like that. So which has a greater maximum? Which one's higher at its peak? Maybe it's a football, so that would be the green one, which is g of x. G of x has a greater max or maximum because 1 is greater than what number? Negative 6. Okay, so that's comparing our two quadratic functions. Let's go on to 1.13. Alright, let's go over 1.13 using quadratic functions. A ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend pass. This year, the resort is considering a price increase. They estimate that for every $5 increase, they will sell 20 fewer holiday weekend passes. Part A, how much should they charge in order to maximize profit? I'm going to underline that word, maximize or maximum. Does that make sense? Okay, step 1. How do we define our variables? Let's have x represent the number of $5 price increases. And then the function we're creating, this will represent the total amount of money generated. And remember, if you're ever getting like intimidated by the function notation, just change that to a y. It's really just x's and y's. Okay, so if I write an equation, p of x, and I say that p of x is equal to the price of each pass, which was $120. So a pass costs $120. but there is a $5 increase for the number of increases. And then the sold passes is going to be, well, I had 680 of them, but those will decrease 20 fewer. So subtracting 20 from the number that holiday passes sold. I'm sorry, number of $5 increases. So my equation is just going to be P of X equals those two binomials or equations we have. And this is not in standard form. This is what we would call an almost x-intercept form. So I'm basically transforming x-intercept form into standard form. Basically means get rid of the parentheses. The book will teach you guys using FOIL. I'm going to show you guys something called the box method. Just organizes it. And we're going to do the same thing as FOIL. You're going to multiply, and then we're going to add or combine like terms. Okay? Okay, I'm going to get my calculator ready here on the side. So I have 120 times 680. That'll give me 81,600. 120 times negative 20. 120 times 120 times negative 20x is negative 240x. 5x times 680 is going to be 3400x. I missed a 0 on the top one. And then 5x times negative 20x is going to be negative 100x squared. So we'll just write this one is a constant. There's no other ones I have, no other x's in it, so that would just become 81,600. If I combine like terms with these two, if I add those together, I will get 1,000, positive 1,000x. So I'm done with those, and then subtract 100x squared. Okay, to put that into standard form, which means we put the x squareds, this is in something we call, pen's turned off. This is called ascending order. You notice the exponents 0, 1, and 2. So if you just flip it around, this is in now descending order. And descending order is what we need for standard form. Okay, so step number 3, find the axis of symmetry. So I'm going to write standard form above it. And I have A equals negative 100. B is 100. Excuse me, that was 1000x. So 1000. Remember, when you're finding your A, B's, and C's, they're just numbers. There's never an x or an x squared in there. So our formula is x equals negative b over 2a. So my b value is 1000. My a value is negative 100. So I'm going to have 1000 divided by negative 200. Feel free to use your calculator. 1000 divided by negative 200 is going to equal negative 5, and opposite of negative 5 is positive 5. Okay, now it says interpret the results. Okay, so before I do that, I'm going to jump over here and just draw a picture. Whoops, I forgot my little trick. Hold it down and it makes a straight line. Okay, in my graph, there's a couple of things I should notice. I first want to get maybe I didn't get an order pair yet, so let's do the function notation of interpret the results. Just take your x value, put it back into the function. Put it back into the function. So that would be this one right here. P of 5 now, so every x value is going to be 5. Feel free to use a calculator with the big numbers. No need to show off your math skills here. So I would get here 25 times 100 gives me negative 2,500. This one's 5,000, and this one you would get that number. So if we do all those numbers together, plus 2,500, this is going to be your vertex. Okay, you don't necessarily need that number, so let's just give ourselves an idea. This is my y-intercept, which is your c value. The vertex, which was higher than that at 84,000. And this is what my graph looks like. And to solve, what they really wanted was that if you take the x value, how much should they charge in order to maximize their profit? Their profit formula stands for P, right? And that was this one. So let's go ahead and take x equals 5 and put it into that formula. Let me write it down here. So P of x equals 120 plus 5x. And we said we're going to put in this 5 here. And P of 5 equals 120 plus 5 times 5. So P of 5 equals 120 plus 25. So P of 5 equals 145. Let's write a sentence to help us understand what this means. Double boxes, that's my final answer. I want to give you a visual for the next part. The ski resort will make the most money with 5, that's what my x value was, price increases, so they can charge, what was the y amount? $145 for each holiday weekend pass. Okay, let's take a look and find the domain and range. And that's the reason why I drew the graph a little bit prematurely, but what values can I get for the x? Okay, because we're talking about profit, you can only start here to here. So X represents the number of price increases, and this represents over here money, right? 84,000. Okay, so you can't have negative. That's the reason why I don't have anything over there. X for nothing over there. Let's so to get that number, let's it's okay if you don't do this part. To help you explain why we don't have that number. But I'm going to put in that formula. Negative 100 x squared plus 1,000 x plus 81,600. And the neat thing about a graphing calculator is I press graph, I can just keep pinching until I get, well, what's that? It's changing the scales for me, if that makes sense. And so what I want to find is the two x intercepts. And that number is 34. Okay, so that's going to be my domain. My domain is going to be 0 to 34. And again, you can't account for the negative side, the red side over here I'm going to draw. Can't have number of increases to be negative. Okay, range is, there is coming from bottom to top, something, 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 and it stops right there at that red number line. So the red number was 84,100. And all of my graph is below that, so that would be less than or equal to 84,100. Now, I can't go below 0 because the amount of money generated cannot be negative. And the maximum amount of money generated is 84,100. All right, go ahead and try the questions below, and don't forget to skip one problem. Press play when you want to see some tips, or if you want me to see me do the same problem. Okay, a county park sells annual permits to its fishing lake. Last year, the county sold 480 fishing permits at $80. This year, the park is considering a price increase. They estimate that for each $4 increase, they will sell 16 fewer annual fishing permits. Define the variables and write a function to represent the situation. So X represents the number of $5 price increases. And the function P of X represents the total amount generated. So the money generated is the price per permit, which is $80, plus the $4 price increase, and the number of increases is X. And total passes is going to be the other one. So we have 480 fishing permits, and those will 16 fewer is minus 16x. Okay, so then I just need to multiply those two. So 80, doesn't matter how you put this on here. My calculator here. So 80 times 480. 16 times 80 is going to give me negative 1280x. 1920x. Negative 64x squared. So negative 64x squared. Subtract those, so 1920 minus 1280 gives me 640 plus 3800, 400. And that's my function. Okay, from there, all I need to do is solve for x. So a is negative 64. B is, sorry, not solve for x. We're trying to find the x value of the vertex, which is of the maximum. So 640, and then B, or C, is 38,400. So x equals negative b over 2a. My b value is 640. My a value is negative 64. So 640 divided by 128 gives me negative 5. So x equals also 5. So the county park needs to have 5 price increases. So they should charge so let's put that number back into our function here. We should put in x equals 5. So p times 5, 80 plus. So what's kind of nice is what? They're going to make to charge $100 per permit. Okay, what's our domain? Let's get a graph really quickly. It's going to look just like the other graph. All right, let's punch it in. And here's a neat thing. Let's just say you should, another way of checking your answer, and then get out of here, is put in the non-multiplied one. And you should actually have the same graph, right? Equivalent functions. Just graph that. And you'll see that this number is, see, even, that's kind of cool. Even stops it right at 0. So cool. 30, 0. So on your graph, we're just going from here to here, so that's 0 to 30. So x, you can buy anywhere between 30 for your domain, and then your range, if you put in 5 into the whole function, let's go back to our graph. You can just substitute in 5 into that number. Graph. And here's 5. Even highlights it in red that 5 comma 40,000. So right there is 40,000. Whoops, erased my domain, sorry. So range is going to be starting at 0, because your profits, you don't only want to show your profits, to what number? 40,000. So my range is between 0 and 40,000. All right, let's go ahead and do number 12. 1.5 squared. And we get 3,645. Oh, I did it again. I know what I did wrong. Okay, that represents, if we did the graph, sorry, that value is at 1.5. This is 3,645, what we just saw. I forgot that we need to put this value into the profit one. So that would just be 30 minus 2 times 1.5, so 30 minus 3, so the answer is 27. They should charge $27 per candle to max their profits. And to figure out the domain, you can just punch that into your calculator. And let me prove to you why they are the same. I need to take a picture of this top one up here. And this is a way your calculator can actually check your algebraic work, which is okay. It's not cheating. Okay, let me put in the parentheses one. 30 minus 2x. The x is not times on the right. The ones in blue are the order of operations. X is a variable. That's towards the second and alpha, the orange and light blue key. 120 plus 10x. Okay, and if I put in the one that we did multiplied through the box, so that would be the 3600 plus 60x minus 20x squared. And what I want to show before I press graph is that if there's two separate graphs, that means what I did are not the same. But if the graphs are the same, like you can only see one graph, that means those two expressions are actually equivalent. One has parentheses, which is the factored form. The other one is called standard form. So let's go ahead and graph it. And we only see one parabola. Does that make sense? And the point of that is to show, again, that they are the same. Now, amazing enough, it actually looks like a it depends how you. So if you put here, let's see. See, I'm trying to get the max there, and you have 1.5, and 3,645 is our total profit, and the number I wanted to find over here was our 0. When it means 0 is the y value 0 and your x is 15. So that's what I wanted to know. This thing does not have all of our, which would be bad because it basically erased everything. Oh yes. I don't know where it is. Bad. At least it's recorded. Okay, so I'll just try to try that again. Files on my iPad. Hey guys, I'm just like you. I go through these technical difficulties. Alright, what's most important is I'm explaining the math. And we said it was like a 30, right? So that basically means this is 0, this is 30. And those are all the numbers we want for the domain, x-axis. So 0 to 30. Those are the amount of price decreases that we can do in this problem. Okay, what is our range? Well, again, I have to kind of start here on the y-axis. That's at 0. Because this is a real-life problem. And it goes to the max, which I think was like 36. 45, I think. And that was question number 12. Yeah, I erased everything. Wonderful. Okay, let's talk about the average rate of change. And this is going to be from an older video, and you just write down these 3 different formulas you're going to see on the screen, and then the 2 steps. And then we'll try some examples below. I want you guys to follow along and do question number 13. And then after that, I want you to just do 2 of the problems.
The average rate of change. The average rate of change of a function y equals f of x between 2 points, x is equal to a and x is equal to b, where they're not the same, is f of b minus f of a over b minus a. Another way of saying it is if you have this function and you pick 2 order pairs on there, you basically find the slope. You've done this all the time with linear equations, but you haven't really done that with something else. For example, the basic function of this one is it's a quadratic. So if you just pick 2 points, let's just say I want to find the average rate of change between the 2 blue points. You're like, Mr. Ng, that's a parabola. Well, all you do is in those same 2 points, you're just going to label them x1, y1, x2, y2, and then put it in. So in class today, we're just going to, here are the steps. We're going to evaluate them separately, and then we're going to use the average rate of change formula. The average rate of change formula is just your slope formula. Alright, and this problem says find the average rate of change of f of x over the interval 1 to 3, and the function f is x squared plus 3x minus 2. Alright, hopefully you notice that this problem is slightly different. Let me give us a visual of what we're doing. If you made a quick sketch, this is a quadratic, so it's going to be a parabola. A value is positive, so it's opening up, and you have a y-intercept of -2. So your graph might look something like this. In this problem, though, your interval is between 1 and 3. On the x-axis, if you look at 1 and you look at 3, the question is, if I weigh it higher than that, what does the graph look like between 1 and 3? What's the slope? Basically, what they're asking for at 1, what's the slope between this point and 1, 2, 3, and something like this? What's the slope of this red 2 points? Okay, so that's what's happening. So, what does that mean for us? You have x values
you basically have two sets of order pairs. And in this first order pair, you know the x value is 1. And you know on the second coordinate, your x value is 3. We basically need to figure out what are the y coordinates here, and then we just need to find the slope between those 2 points. So the first thing we're going to do is evaluate separately. Say that, class. So what I'm going to do here is I'm just going to take my function and I'm going to take one of my coordinates there's my input of 1. Again, you can always do this with your calculator. So every x value we're putting in 1. Class 1 squared is 3 times 1 is, and I have the minus 2. 1 plus 3 is, and 4 minus 2 is 2. So f of 1 equals 2. My output is 2. The order pair is 1, 2. This is my first order pair. Now in the other formula that you guys saw, to make it more complicated, another way of writing the order pair is x1 f of x of 1. You're just basically putting the 1 into your function and you get an output. Okay, so we've done the first order pair. Let's go ahead and do the second order pair. So I'm going to have the same function, and I'm putting the blanks there so you have enough space to fill it in with our input. My input's going to be a 3. Every x value put in 3. So now I have f of 3 equals 3 squared plus 3 times 3 minus 2. Class, what's 3 squared? 3 times 3? 9 plus 9 minus 2. F of 3 equals 16. 16 is the output of our second point. So what we did is we evaluated separately, and next, now I just need to find the average rate of change. Class, what's another word for average rate of change? Basically just finding your slope. The fancy words here is you're finding a secant. Partner A, tell partner B, what's the formula for slope or average rate of change? Elvis, tell us a formula for slope or average rate of change. I'm going to highlight the minus sign. My y2 value is 16 minus 2 over 3 minus 1. And now I have 16 minus 2, which is 14 over 2, and 14 divided by 2 is 7. The average rate of change is 7. So to review, in this problem they give us an interval notation. We evaluate them separately, and then you find your average rate of change. F of x on the interval between 3 to 4. Okay, what does this mean? If you made a sketch of the graph, I just make a really quick sketch. I know that this is quadratic. It's opening up. I know that its y-intercept is 0. So it might look something like this. And really what's happening is we're looking at on the x-axis between 3 and 4. So let's just say this is 3 and this is 4. Basically what we're doing is we're trying to find the slope between these 2 points. The hard part is we only have the x values and we don't have the y values to eventually use the average rate of change, which is basically slope. So there's multiple ways of doing this problem, but I'm going to evaluate separately. So that's my first step, evaluate separately. What does that mean? I'm going to take my function and I'm going to put in 3 into my x value. No! Sun's calling. Okay, so we're going to take now 3 and put it in. And basically what we're doing here is this. Forgot this part. Is basically I need 2 order pairs. I have 3 comma something and 4 comma something. And what I'm trying to do here is I found out the 3 and I'm trying to figure out the y coordinate. Okay? So if I put in a 3, 3 squared is negative 2 times 3 is 9 minus 6 is 3. So I have f of 3 equals 3. Remember, this is an order pair, 3 comma 3. Okay, now I'm going to do the second order pair, so I'm going to evaluate the second one. Same thing, I'm going to do f of into our function. Let's use orange. Now I have a 4. You can always use your calculator to verify. 4 squared is negative 2 times 4 is 16 minus 8 is, so f of 4 equals 8. So I did all of that work so I can get this order pairs. Now I can find the average rate of change. Another word for average rate of change, class, is partner A tell partner B what's the equation for slope. Raymond, what's our equation for slope?
Y equals y squared minus y1 over x2 minus x1.
So remember, you can label these. So x1, y1, x2, y2. So I have the 8 minus 3 over x2, which is 4 minus 3. And then our slope, or a fancy word they also call it secant, 8 minus 3 is, and then 4 minus 1 is 1. So I have a slope of 5. The average rate of change is 5 is my answer. So to review, you don't have, to find the average rate of change, I'm looking in between 2 points. They've given me an interval, and I need to evaluate them separately to get your y values. Remember, a fancy way of actually writing this is they call that f of x of 1. That basically just is a fancy way of just saying is the y value after you put in your x value. Same thing over here, that'd be called f of x of 2. And then once you get your 2 ordered pairs, then you could just find the average rate of change just using the slope formula, and we got 5 as our answer. All right, for question number 15 here, I just have the solution. So you're going to do the same thing, evaluate it separately, and use the average rate of change. You're going to separate the, let's try this. I already used that one. Let's use orange. Well, we're first going to evaluate it at -5. And that's why I put it here at every x value into the function. And then you get an answer of 91. And then the second part of the interval, you're going to put it into the function as well. And you evaluate it, and you get 61. So then you basically you put in -5 into the blue, and you got an output of 91. So your order pair there is -5, 91, which is my blue order pair up here. And then if you put in 5 for the green, your output is 61, and I put it over here in my second order pair. Trick or hint is label. Label means to have these things up here at the top. x1, y1, x2, y2. So when we use the average rate of change, you're going to substitute in there, highlight your negative sign, and you get -3. I'm going to show you the solutions for the rest of these. Number 16, split them up. I put in -2 for the green, blue 2, you got f of 2 equals 21, so that's my order pair, and then green -2 is 17. I decided to use the other formula just to show you guys. It's pretty much the same thing if you're doing the function of f of b, so that would be the blue. So f of b here was 21. Let me show you what I did. This is f of b, that's the output, so that would be 21. I'm writing 21 right there. When I put an a into the function, I got 17, and that's why I have 17. And then your b value was 2, and then your a value from up here is -2. Simplify that and you get 1. 17 is the same exact thing. Separate your interval. Remember, the interval that I'm talking about right here is not an order pair. It's saying start of the graph at -3 and go to 3. Put in -3 into the function. There's my work in blue. I got an answer of 7. Do a second mini problem. Put in 3 into the function. This one over here. Whoops, that's too dark. And you get an answer of 7. You get these order pairs up here at the top. Write down your formula, substitute them in, and you'll get a slope of 0. And number 18, separate them. I have -4 for the red below, put into the function. You'll see my substitutions. Every x value is -4. And then for the green, you're putting in every x value is 4. Remember, don't forget to use PEMDAS, which is parentheses first. You're not multiplying. Right here is a common mistake. You're not multiplying first. You're doing exponents. So do not do -2 times 4. You'll get an answer of 7. Make sure to label x1, y1, x2, y2. Always write down your formula, highlight your subtraction sign, and then this problem you get a slope of 8.
All right, let's go over question number 19 here. And I'm going to take that interval here, and that's -3 here is going to become my first order pair. So -3, x1, y1, it's an order pair. And then I'm going to look over here on my table of values here to the right. The left column is your x values, your right side is your y or f of x, they're the same. And I need to find a y value. And the y value there is, in this blue box, 0. -3, comma 0 is my order pair. So let's write that down. And then I'm going to take my second part of the interval and make a second order pair. So you're not technically evaluating, but you're kind of separating them. 3. And this is my second order pair. That's why we call it x2, y2. So go ahead and locate on the table of values one that has a 3 there, and it's 12. 3, comma 12. Let's write that down. And so now we're going to do the second part of the average rate of change formula. Always, always, always write down your formula. M equals y2 minus y1 over x2 minus x1. What's hard for students is the formula has a minus sign. So let's go ahead and substitute these in. x1 is -3. So every time I see x1, I'm going to write -3. y1 is 0. So in my formula, every time I see y1, I'm going to write 0 right here. And then every time I see x2, I'm going to write 3. So there's x2, I'm going to write 3. Y2 is 12. So every time I see y2, I'm going to write 12. Now everything else for the formula here, let's go ahead and write it out. M equals my fraction line. Remember, every time we did substitution here, good practice is putting in parentheses. And let's go ahead and highlight that pesky little negative sign. This is a common mistake for students. That's why I'm highlighting in red so you can kind of visually see it. And now we have m equals 12 minus 0 is 12, and the opposite of -3, or you can think of it as -1 times -3, which becomes +3, so 3 plus 3 is 6. So m equals 2. Our slope, or average rate of change, equals 2. Let's go on to question number 20 here. And same thing, you're going to take the interval and make it 2 order pairs. So the blue one, the -4, is your x1 value, and the red value is your 4, and then you see them should have been blue. On the table of values, -4, my f of x value, or my y value, is -27. That's how I got -27. And for the red one, 4, comma, -27. Always, always, always write down your average rate of change formula. A good tip here is to always label your order pairs, x1, y1, x2, y2 there in yellow. Substitute it in. And you be careful there, you'll get 0 divided by 8. Put in your calculator, it is 0. Feel free to put those into your calculators. -27, and the opposite of -27 is +27, so it's essentially 0. In that case, canceling there is 0. And that one becomes +4. So 4 plus 4 gives you 8. 0 divided by 8 is 0, not undefined. And then a little more quickly, number 21, left side of the interval, -2 in black here, becomes the x1 of my order pair. And you look on your chart, that's -3. and then the right side of the interval is 2 in blue. Look on the chart, you get 9, so that's my 2 order pairs. Always write down the formula, substitute it in, simplify, and you'll get a slope of 3. Question number 22, same thing, separate them, get your 2 order pairs. Look at your table of values for your 2 values. In black, that will be negative 39. Blue would be 1, 5, 1. Make sure you label your order pairs x1, y1, x2, y2. Write down your formula, substitute in there, and simplify. Hopefully the change of colors is helpful, and you should do that in your work too if that helps you. You get a slope of 4. Question number 23. Separate your 2 intervals to get your x values. Negative 3, look on your chart, you get 27, and the blue 3, 27. And you should be using some math sense here. If you actually graph these order pairs, left 3 up 27, right 3 up 27, you'll recognize it's a horizontal line. That line has no slope, it's not a hill. And so that should be our answer. Slope is 0. So no slope means 0. Write down your formula, highlight your subtraction sign, substitute it in there, and simplify, and you get a slope of 0. M equals 0, box your answers. And question number 24, same thing, separate them, black, green, negative 2, and 2. Look those on your table of values, negative 2, 12, and 2, negative 4. Don't forget to label your order pairs right there, x1, y1, x2, y2. It's a common mistake for students. Always write down the formula so you don't mix them up. A lot of students try to skip steps in their head, but do it on paper. Highlight your subtraction sign, substitute, and you'll get an answer of negative 4. Alright, so let's go over 1.16 averaging, find the average rate of change from a graph, or more context. The graph shows the amount of money the United States has spent on sports footwear since 2005. Part A, use the graph to estimate the average rate of change spending on sports footwear from 2005 to 2015, then check your answers algebraically. So looking at my graph here, let's do an estimate. You don't need to, but that's what slope is, right? You're trying to find the rise over the run, the changing of the y over the change of x. So slope, m, is the change of y over the change of x. What does that mean? Well, this green here represents my vertical. So the vertical change, or differences, or subtraction. And I think that's like a, 21 minus 16 is like 5. And then the change of x is right there, the bottom of that triangle. And that's, if you look at there, it's like a 0 to 10. So, 5 divided by 10 is not 2, it's 1/2. So our 0.5 is my guess, is our estimate. So we're going to do the same thing we've done before. We're going to evaluate those separately. So just get your order pairs, and there's really only 2 order pairs on the chart. Now, years since 2005 means if you put a 0, 2005 plus 0 equals 2005. So that is where 2005 is. 2010, from 2005, you add 10, you get 2015. So right there, that represents 2015. That's what it means when it says year since 2005. Okay, my 2 order pairs. 2005 is 0, 15.72, x1, y1. And then my second order pair is 10, 20.99, x2, y2. We're basically doing the same thing we've done before. Write down your formula, always. Highlight your subtraction sign. M equals my y2 value is 20.99. My y1 value is 15.72. x2 value is 10. Make your substitutions in parentheses and 0. So if you go ahead and subtract those, don't feel bad to use a calculator. I get 5.27 over 10. So over 10 years, there's an increase of $5.27 billion, or if you divide that, you get 0.527. Now, why did I put it over 1? That'll help us with context when I write this. So, a good way of answering questions is taking the question and making it a statement. So everything here in blue, I'm just going to write. Let's write that down. The average rate of change spending on sports footwear from 2005 to 2015. Okay, now is my slope positive or negative? My answer there is positive, so we can say the word increased. Now it's kind of weird to say 0.527 and then look at your y-axis, change of y over change of x. The reason why I'm pointing that out is it helps us with context. So that's spending in billions of dollars. So I'm going to write $0.527 billion. If you actually multiply that 0.527 times 1 billion, it's essentially 527 million. Now our fraction, we did say over 1, so the change of x there is in years. So the x-axis is years, so I'm going to say over 1 year. That was part B. Okay, question number 25. Food. The graph shows the number of people in the U.S. who consume between 8 and 11 bags of potato chips in the year 2011. Use the graph to estimate the average rate of change of consumption from 2011 to 2016. Then check your results. Remember, there is 2011, and add 9 there, you get 2020. Now we're just going to 2016. So that would be 2011 plus 5, so 5 comma 55.35 is my first order pair. Doesn't matter if you mix them up, x1, y1. And then 0 comma 42.97 is how much consumption was in the year 2011. Label them x1, y1, x2, y2. Write down your formula always. Don't forget to highlight the negative signs. So my y2 value is 42.97 and my y1 value is 55.35. My x2 value is 0 and my x1 value is 5. Let's go ahead and subtract these. $42.97 minus 55.35. I'm putting in my calculator here. Negative 12.38 over negative 5. Of course, negative divided by negative is a positive, so you could say 12.38 over 5 years. Or in context, we can kind of say 2.476 over 1, right? You can always make it over 1. Let's go ahead and highlight the sentence that we're going to use for context. It's always great to write complete sentences. The average rate of change of consumption from 2011 to 2016. All of those dots are going up in a positive direction. So we can say increased. $2.476, looking for context here. Change of y over change of x, so look at your y-axis. Consumption in millions. Over 1 year. Again, you could have said 12.38 over 5 years, but it's just easier to say it over 1 year. Number 26, earnings. The graph shows the amount of money Shyla earned each year since 2008. Use the graph to estimate the average rate of change, and it shows earnings from 2008 to 2018, then check your answers algebraically. Remember, 2008 is here at 0. And 10 here would be 2018. Oh, wrong line here. I think that line should go to the right. Oops. Should be that order pair. So 10, comma 7.2 is my first order pair. Again, when you're picking your order pairs, it doesn't matter the order. Just make sure you're labeling them correctly. What I mean by that, x1, y1, x2, y2, doesn't matter. X's do go first and then the y's. So we're evaluating those separately. Write down a formula, average rate of change formula. Always write it down every single problem. Highlight the subtraction sign. Y2 value is 2.1 minus 7.2 over x2 is 0 minus 10. Then punch that into my calculator here. You should be using a calculator. Negative 5.1 over negative 10. So you could say 5.1 over 10 years. Or if you divide it, we get 0.51 over 1 year. Let's go ahead and highlight the sentence we're going to use. We're writing it, turning the question into part of our answer is part of context. The average rate of change of Shyla's earnings, which I forgot, from 2008 to 2018, the box is positive, so increased 0.51, $10,000. Matter if you actually multiply that out, it'll equal $5,100 over 1 year.
24 hours in a day, and I get to do math, hey hooray. Y equals mx plus b with Mr. Ng, we're making history. Pythagoras, Euclid, and Gauss learn the math and you'll become the boss.